Okay, I'm going to ask the first question. So this could, anybody can answer this. In terms of justifying projects, can you talk a little bit about how you got buy-in from your companies and what that was like? Is it easy to get operations, to get them on board? Is it easy to get the capital expenditures? In the case of a separate energy group, sometimes these groups work in isolated environments. Can you talk just a little bit about how you started each of your projects?
Yeah, for me, really all we had to do was find the opportunities for reduced energy costs, and with the 521, working with a couple of the process engineers, we just did some simple mass and energy balance calculations. Is this working?
Oh, I'm gonna hold closer.
Right. Oh, okay. Okay. I'm not Justin Timberlake, but all right. So, it was a matter of him and I just doing some simple energy balance calculations to say, well, if we can get a 5 to 8% performance increase on the pressure and temperature control, that directly results into X amount of steam reduction. So the simple math, we're able to present it to management as well as presenting to engineering and management a couple of demos of some real live examples of what the software does. How they say seeing is believing. So I was also able to use some prior exposure to the software back when I worked at Savannah River years and years ago. We did a small plant triage installation there as well, and it worked in, and so I was able to kind of give them a verbal that yes, I saw this work. So that was my justification, just a simple opportunities for energy reduction.
How about you, David? Any comments?
In the case of the fuel gas system, that was a site that had tried so many different things for so long. They had some DMC Plus applications running on their process units, but they never really connected to things. And we kept saying, we proposed it a couple years prior to when we actually did it, saying, hey, we could do this. And they thought about it, and lots of regurgitating around and thinking about it and coming up with more procedures. And then finally said, well, why don't you go ahead and do it? The cost was for our services were not that high because it was not that much time on site. But it was more in the case of we've never tried this before. And we had not done a utility DMC before. The second one actually fell from the first one. The first one said, hey, the site had also had some DMC Plus applications on the process, and they had heard about what we did with a fuel gas system. They said, why don't you try it on this system? And so it was actually the site's idea that we just came in, and again, it was a matter of a few weeks worth of work on our part. And then since then, we've had a lot of demand for more things that people say, hey, well, I got the same type of problem. Let me look at it and go from there. So the first one was tough to get people to buy in from that site.
So in terms of this one might be a little harder to answer, but maybe I can direct this one to Expertune or AspenTech. Resource constraints seem to continue to plague refineries and chemical plants today. There just aren't the people to go around and fix things anymore, and many times folks are busy fighting proverbial fires and doing not necessarily the work in the right order. From a supplier or technology perspective, George or Robert, can you talk a little bit about how you're making it easier to deploy solutions?
Sure. There are a couple of key things to that. I mean, everybody's facing that same kind of issue pretty much everywhere we go in the world. The couple of things that we do to try to address that is, first of all, let the computers and the software do the grunt work. I mean, let them crank through the analysis. Everybody has a data historian with piles and piles of data in it. You don't necessarily need to crawl through that individually one by one. You need to let the software do that for you and point you to the right place. The second thing, and I think Michael hit on this, very important, is prioritize. You don't have enough time to work on everything. So how do you know which things are most important to work on? And that's a combination really of technical factors in terms of just how bad is it on this unit compared to that unit, or this controller compared to that controller, but also the economics, the relative economics within the plant. And we all know that there are some things that are much more important than others. But so combine those technical and economic factors to really help focus the attention on the place where you can do the most and the most quickly. So that's kind of the approach we're taking.
Yeah, I'd say that's the same basic tack that we're on. I'd add to it that I think you can be sort of smart about where you point the automation. And I think that one of the things you heard in Michael's presentation is that these guys have to be, a jack of all trades, right? They're doing the network, they're doing the instrumentation, they're doing the modeling, they're washing the dishes. And that's a lot to ask people to do. And so if you think about where the skill sets are, it's a little easier to find people with deeper process domain knowledge than it is to find people with deep controls knowledge. So to the degree that you can use automation to provide that control systems expertise and leverage the process knowledge, then good things tend to come from that. So.
Okay. Thanks, guys. Question from the audience?
Yeah, my name is Andreas Ranzhofer, BASF, Germany. I have a question basically to David. You presented examples optimizing the utilities. Yes. And I could imagine within Exxon you would have thousands of applications within the processes. So that is my question. How far do you deploy those technology in the process plants? And the second one is, all these projects seems to be very beneficial, payback time of some weeks or a month. So what do you think, how far you have reached already the utilization within Exxon, or what is the potential?
That's a great question. I wish I knew the actual answer for that question. We've looked at it a number of times, and I think of that, and some of our leadership has time about 4 or 5 times that we've reached the maximum. And that's over the last 20 or so years we've been applying this technology. So even 10 to 15 years ago, we thought we'd reach our maximum. And then all of a sudden, something broke loose. Things became easier to apply, and all of a sudden, new opportunities open up. And the software became more sophisticated as well. So it's hard to say. I mean, last year we actually produced, we implemented a lot on processes. Utilities is relatively new. Most of the focus has been on processes. And last year, the credits we got from for applying new applications was the biggest we'd ever had. So over the previous 20-some-odd years, we've been applying this technology. So it's hard to say when the end is going to be, but we keep finding more uses for the technology.
I'd say, too, that the economics are dramatically different than they were 10, 15, 20 years ago. That is, the cost of implementing some of these technologies had sort of a minimal cost that you simply couldn't justify for certain kinds of projects. And yet if you look at the changes in commercial models and those kinds of things, you now have not only technological scalability but economic scalability. So the ability to use something like model predictive control in some of these applications is now cost effective, whereas in the past it just simply wasn't a viable technology choice.
Any other questions from the audience? Okay, while they're thinking, I've got another one. What about the use of key performance indicators? Some of the research we're doing shows that companies are being more visible and developing stoplight format and specific ways to measure controller performance. Can you talk a little bit about this from both the practitioner standpoint and the technology supplier standpoint? Where do you see KPIs going with process and energy optimization?
Talking about, we track different parts of our organization track like energy usage, and they'll do the same thing you just mentioned. As I was laughing about it, the red, green, and yellow. But we also track our performance of our model predictive controllers throughout the company. And we have a chart of well more than 100 applications, and with each red, yellow, and green about the service factor, and we have another metric as well that we track as well on that performance. And those are aggregated and reported to management as a one number and per site and then an overall target. And there's a lot of senior managers look at that number, among other things, to track that. So yes, we're using that heavily.
Yeah, it was the same thing with us. We were able to configure, real-time energy consumption cost, and we were able to, have that information trended, and you can update it on the control system with the current cost of fuel oil or steam usage. So it was a directly measurable before and after as well.
We've spent a lot of time thinking about how to measure the performance of control systems, and as we've been doing this for 3 decades, looking at that. In fact, we have over 80 metrics of performance on every individual control loop that can be done. Now, that's not to say that anybody would want to ever look at all 80 of those. The key part of that is if you want to have control over something, you've got to start by measuring it. And so we look at ways to measure the performance of the control system and then use those measures to diagnose specific aspects of performance that goes with that. So sometimes you're determining a KPI or a metric not necessarily because you want that number on the plant manager's desk, but because you want to use that to analyze and diagnose at a deeper level what's going on in the system. And then what gets provided out to people is that diagnostic with some advice. So we're doing a lot of that with control system performance. And I would encourage people, even if you're only going to measure a few things about your control system, think about things like what percentage of my control loops are running in manual. And that's about as simple of a metric as we can think of for control performance, and it's pretty critical. and I say that percentage of loops in manual is not so much a diagnostic itself, so much as it is a symptom of an underlying problem. So if you're going to start anywhere, I'd say start with that, and think about that as a metric of the performance of your $10 million control system. If 20% of it's running in manual, how well are you doing with that today? There's plenty of opportunity for improvement. That's a typical kind of number that you'd find in an oil refinery, a petrochem plant, something like that. So there's lots of opportunity out there to make improvement.
I guess I'd add too that from a vendor's perspective, we see multiple levels of this thing, right? And at the lower operational levels, looking at control performance as an example has gotten better, and there are pretty well established measures for that kind of performance. But if you go back to sort of the original theory behind a key performance indicator, it had some sort of a predictive element to it, right? That if you maintain the KPIs, then the ultimate performance measured in economic terms would turn out the right way. And so there seems to be this gap, and there's a couple of different problems. One, it's very easy to create a spaghetti bowl of KPIs. And second, people do funny things when you put information in front of them. And I'd like to use an example of the architecture in New Orleans. I know this sounds strange. I'll bring it all home in a minute. There was a tax law in place in New Orleans that the amount of tax you paid on your property was based on the width of your house. And so if you drive around New Orleans now, you see what they call shotgun houses or camelback houses. They're very narrow and very long with a second story sort of tacked on to the back end. And that was a way of sort of getting around the tax codes. The point is that you have to be careful what you measure because people are going to react to it. And if there's a gap that I believe still needs to be addressed, is there's still this chasm between the root level KPIs that we use to look at our technology and our assets versus that final economic performance. And one of the reasons, I think, is that if you look at the way that we think about costs, we're still relying on what financial types call GAAP measures. And we're using things like cash flows and balance sheets and general ledgers and those kinds of things to sort of assess the financial performance of some of these technologies and assets. And yet when you look inside the way that we use our assets, those cost models, which by the way most of them were created in the 40s and the 50s, are woefully inadequate to sort of help us understand where we're spending our money wisely and where we're not. So I'm more encouraged about our ability to develop functional, adequate sets of KPIs at the lower operational levels, and am deeply troubled by our addiction to using traditional financial gap measures to think about performance. And I think that if you go back and look at some of the work that ARC has done, going back to the CPM models and some of the things they asserted before, you sort of see that woven into the message that the way that we think about cost as a measure of performance is something that we all need to do a bit of work on. So we're much better at the operational KPIs. I think it's like a KPI is just a model, and in modeling, a parsimonious model is better. And so I think that that's the next challenge, is how do we stop creating spaghetti bowls of KPIs, and how to create things that when we aggregate them together, we finally get that view, that economic view of the way that we operate our assets that we're really after. And I think that's the key challenge.